Okay, good. Okay, good morning, afternoon, everyone. Today, I'm excited to talk about the AI agents and how we're doing a lot of exciting things with leveraging Oracle Database 23 AI with LangChain to build intelligent, autonomous applications. I'm here with Ashu Kumar, who's also going to be helping with the Q&A. We're both from the database product management team here at Oracle. And we're just going to go ahead and explore how AI is evolving a lot of the things we do day to day, such as interacting with simple chatbots to unleashing agents that can reason, plan, and take actions to accomplish a variety of complex tasks like humans can. So let's start by understanding where we are in the AI journey. So AI has evolved through distinct phases. I would start off with classic AI machine learning. And this was all about recognizing these patterns in data to perform specific tasks like prediction outcomes, detecting anomalies, and providing specific recommendations. This was powerful at its time, but also limited to a lot of use cases that it was trained for. And then we have generative AI that spawned with an introduction of large language models. And this was a game changer because AI could now create new content based on prompts from users. And we saw capabilities like summarizing content, assisted authoring, and answering questions based on trained data sets or fine-tuned data sets. But it was still reactive. You ask and it responds. So now we're entering the era of AI agents where it delivers powered actions and can answer complex questions, deliver guidance, also complete tasks within context of a process. They're also proactive, not reactive, like the current phases of AI. It's based off of more to kind of like the Retrieval-Augmented Generation context. It uses LLMs from private and confidential information to, pretty much streamline and incorporate vector databases like we use in Oracle 23 AI to ultimately give these agents access to enterprise data securely and efficiently, and also accurately, because RAG isn't always the best. Sometimes it can hallucinate, but when you add some of these elements like vector databases, agents, it allows the process to be a little bit more refined and accurate. And then lastly, we have finally the MCP server, which is called the Model Context Protocol. Essentially, this delivers tools and systems to agents, which enables them to access external tools and systems for secure actions. And this is the foundation that makes it truly autonomous and supports these agents' interactions as well. The opportunity here is massive because we can now assemble, create, automate, and embed custom AI agents directly into enterprise workflows. And it's not just about adding AI as a separate tool, it's about making AI as a native part of how your business operates. So these agents become embedded in applications and processes that teams and we see people almost use every day.
What would you like to order?
So this is an example of a autonomous AI agent workflow.
The fries large, the Coke medium, give me 5 Cokes and 2 fries. And the fries would have honey mustard and the Coke would have ice.
So to confirm, you'd like to order 2 large fries with honey mustard and 5 medium Cokes with ice. Is that correct?
Yes, thank you.
Thank you. That'll be $25. Please pull up to the window.
So there's just so much you can do with the power of AI. So here's more of a concrete example of how this works within Oracle. Here we have an Oracle AI for HCM example. So the employee asks, I have questions about our benefit offerings. How much life insurance can I get, right? When will I reach my maximum contribution level for retirement savings? And in the traditional model, that employee would need to dig through documentation originally and maybe send emails to HR specialists and manually track everything. But with an AI agent, specifically our benefit analysis agent, the experience is a lot different, where the agent allows the flow of work during benefits enrollment. And here's what's happening under the hood in Oracle AI Agent Studio, where we configure, assemble, and test these agents. We have the knowledge documents like what's new, guides, and calendar and email tools for scheduling and communication We also have Fusion application data like employee compensation and records, and calculator tools for running the numbers, and as well as the email tool for sending out emails. So the agent can plan and optimize actions using all these tools and essentially sift through whatever is necessary to help get that answer provided to the employee. So we recognize that everything, in every organization has different needs and different levels of AI maturity and adoption. So we're really flexible here in how we provide a choice for you to build and deploy agents. You have 3 paths essentially. You can build agents into your applications, where we have over 50 AI agents already ready to go for Fusion Application Suite. They're also production ready and can be deployed immediately. And then you can build agents using a broad set of tools, using our ready-made tools and platforms to assemble custom agents without starting from scratch, which is pretty, timely. For example, if you want to spin up an instance and you don't know much about agents, I think that would be pretty useful as a developer to test. And then you can also build from scratch if you want a little bit more customization for organizations that need, that customization. And you can also build this using open source tools and frameworks like LangChain and so on. And the key here is with this slide is, we want to support where and how you want your agents, so you can have faster time to value and also have customization all in one. So let me break down what each path looks like in more detail. So starting from the left, we have agents into your applications. So we have 50 plus AI agents across the Fusion application suite. They're categorized into functional agents, domain-specific tasks, supervisory agents for oversight and governance, and utility agents for general purpose helpers. In the middle, build agents with ready-made tools using the OCI agent platform. This includes RAG tools for retrieval-augmented generation, code tools for execution, SQL tools for database queries, and the ability to create custom tools. And this is kind of the sweet spot for most organizations because they have the powerful capabilities without really reinventing the wheel. And then on the right, we have the build agents from scratch using open source tools and frameworks, where you have access to state-of-art foundation models like OpenAI, Grok, Meta, and Cohere. We also have GPUs for training and inference. And everything is built into the Oracle data platform. So you have a unified data platform that handles all your data needs. This slide also shows some of the most popular open source frameworks like LangChain, LangGraph, and you can use these, and we'll focus on the presentation building Oracle agents with LangChain. So what makes Oracle uniquely positioned to support growth end-to-end is the complete stack. So at the foundation, we have knowledge sources. This is your data platform. So 23AI is a unified data platform for all data types. It's our converged database. So it supports obviously the newest vector data type, relational, spatial, JSON, and graph. And in the middle layer, we have models, the AI agent itself, and the LLMs that power it. And this is where the intelligent lives. And at the top, we have applications where the agent actually delivers the value to end users. Most vendors can give you 1 or 2 of these layers. Oracle is one of the only companies that can deliver the complete stack fully integrated with enterprise-grade security and performance. And this doesn't just apply to Oracle apps. It also applies to how we're uniquely positioned to support AI for our partner applications as well. You can see a plethora of our applications that we support down here as well. Maybe some of them are familiar. And to reiterate, whether you're using Oracle applications or partner solutions, the architectural approach is the same. The converged data platform at the foundation still supports everything above it, making AI accessible for your entire technology landscape here. So let's define agentic AI a little bit more clearly. So it refers to AI systems that can autonomously perform tasks, make decisions, and take actions to achieve specific goals. And the difference between agentic AI and regular AI is autonomy and goal orientation. So you can give an agent a goal, not step-by-step instructions, and it figures out how to accomplish that goal. And the core components that exist within an agent are the LLM, which is the reasoning, and it performs the processing of information, generates the response as well. and also allows the agent to understand, the language, context, and intent. And then we have the tools, which were spoken briefly about before as well, which are external capabilities that extend the agent's functionality, like database access, PDF creation, web search, and any other tool that the agent can use. And then we have memory, which is the ability to retain the context from short-term and long-term interactions. And then reasoning pattern, which is the framework for decision making. And all of these work together to kind of create the system that the agent uses today. So how does an AI agent actually work? So one of the most powerful characteristics of AI agents is the reasoning and self-reflection that it can do. It can learn from its prior actions by reflecting and adapting. It can refine its actions. It can also use languages and tools to think out loud, and also use APIs for interacting with the world. So it makes its decision-making process a little bit more transparent and auditable. Being able to know what your LLM or your agent's thinking and being able to reason with it and possibly even correct its train of thought is very powerful. A lot of organizations love that transparency because you want to make sure that what is going on is correct and being done correctly. So that is very important. And then we have memory, which provides, as mentioned, the continuity and learning capabilities to AI agents. Without the memory, every interaction would pretty much start from zero, which isn't how humans work, and it's not how agents should work either. So as mentioned before, you have the short-term memory, which is kind of like the temporary context window. It's managed during the current interaction. And then you have the long-term memory, which is more persistent and often implemented with vector stores for faster retrieval systems. And then, so tools pretty much allow agents to perform any actions that are not normal from general purpose LLM capabilities. And it allows them to have access to real-time information. So you can set up an agent to retrieve current data like stock prices, weather, and news. And if you had a use case where you needed all three of those different tools to correlate together to create some type of use case or output, or even some type of application, you could. So that's what the agent is here to do. It's essentially a superhero if you think about it. I don't know if you guys seen Incredibles, but the mom who could do multiple things at once. That's what I think of when I think of the agent. So anyways, we have the API integration as well, which is huge to help agents interact with proprietary or private systems for advanced tasks, even databases, for example, to allow you to query your database or call your internal APIs. There's so much to do, and it's just amazing how limitless this is. So let me show you what this looks like in code. This is a Python function that initializes the LLM model for an agent. We can use standard agent classes from frameworks like LangChain, Llama Index, or Hugging Face. And the key is to use a strong LLM for reasoning in this example. We're using Cohere's Command R model through OCI Generative AI. You can also change the model to the newer one, Command A, if you want. So looking at the configuration, we're setting the model ID, the service endpoint for Oracle's generative AI service authentication, and some model parameters like temperature and max tokens. And if you guys don't already know, just temperature controls how creative or deterministic the responses are. So 0 means very deterministic, which is good for agents that probably need to be more reliable and consistent than average. And this is also all running on Oracle Cloud Infrastructure, leveraging our generative AI service, which means you get the enterprise grade capabilities there as well, and performance. This prompt is used to give directions to the agent. So the prompt defines how the agent thinks and operates. Without the prompt, the agent is it doesn't even know what it identifies as. So the prompt gives the agent purpose. So you could tell the agent you are an assistant that can search documents, look up emails, and create PDFs. And that's the role. So that's complete role definition for the agent. And then you provide some format for reasoning, like question, what is the user asking, the thought, the action, which tool to use, and what to pass the tool, and the result from the tool, and then repeat it if needed, and then give that final response back to the user. And we also include chat history, so the agent has context from previous interactions. And this prompt engineering is pretty much state of art. So, you know, there's a framework you should follow, and the better your prompts, the more effective your agent will be here. So AI agents are pretty powerful, but they also introduce a lot of challenges we need to address, such as tool misuse. So AI agents can break boundaries and leak information if not properly constrained. So for example, if I'm providing AI agents access to some proprietary tool or source, you know, where things might be confidential, you know, that's a concern. So an agent with, or an email or access to database tools could potentially, you know, expose or extract sensitive data and send it externally if it's not designed with proper guardrails. Also lack of control, because there's no fine-grained control over which tools are available in what context. So you might want an agent to have read access to data, or read access to data, but not write access, or access to certain APIs and avoiding others. And then there's no built-in mechanism for auditing or compliance. So how do you know what your agent is doing? How do you ensure it's complying with regulations? Traditional architectures don't have good answers here. So this is where model context protocol becomes very, very crucial. So just to explain a little bit about what it is, essentially it's an open source protocol that standardizes how applications provide context to the LLMs or the AI that you're working with. So a lot of people like to describe the MCP like a USB-C port for AI applications. So, you know, every device has its own proprietary connector, and USB-C standardizes the interface, and suddenly everything could connect to everything else. So MCP kind of does the same thing for AI. It uses a standardized interface for LLM data connections. It also has a simplified integration that solves the way we call the NM problem without a standard. It also has tool and data discovery capabilities where agents can discover what tools and data are available to them dynamically. And it also addresses the security and access control here, where MCP server acts as a gatekeeper, enforcing a lot of permissions and access policies to the application. And it's also being widely adopted across the industry, as it was originally introduced by Anthropic in November 2024. So I think this slide is pretty beautiful in a sense that it explains what I just said in a more relatable context, and a lot less technical specs. So I would like to use a metaphor here, ordering at a restaurant. So the MCP client in this scenario, if you will, is you, basically the diner. So you're the one with the needs and the requests. You know what you want. Maybe it's data from a database, or you need to execute a function. So you initiate that conversation. The MCP server, who is the waiter, is the intermediary that understands your requests. So he knows or she knows what's available on the menu and knows how to communicate with the kitchen. So the waiter doesn't cook the food, but they do translate your needs into something that the kitchen can understand and act on, and then bring back the results to the waiter or the MCP server. So the MCP server or the waiter will go to the data source and tool area, which is the kitchen in this analogy. And this kitchen could be your Oracle database, an API, a file system, or any tool. And the kitchen processes that request and prepares what was ordered. So the beauty of this is you as the diner don't need to know how the kitchen works. You don't need to know how the recipes or the cooking or what the cooking techniques are. You just need to know how to communicate with the waiter. And the waiter provides a standardized interface so different kitchens can be swapped in and out without changing how you order. So this separation of concerns makes AI systems a lot more modular, maintainable, and secure. So let's look at a practical example where we have an agentic AI travel assistant. So we have an agentic AI system where this travel assistant uses an agent-based architecture that helps enable autonomous decision-making, personalized recommendations for, when you're trying to get generic traveling information. So the agent will, accompany you along this journey and understand your preferences, constraints, and context. We also use Oracle 23 AI integration. So we have vector store, semantic search, and retrieval-augmented generation to help push this thoughtfulness out. And this is the custom agent logic that determines the optimal response flow here, agent.py. And then we also have Oracle 23 AI vector search. So this data type will help perform the similarity queries. So if you say something like, I want somewhere warm with good beaches, the agent can find destinations that will look semantically close to that. So all that's pretty cool. So now it's your turn to build an agentic AI application with LangChain and Oracle database. Before I go into the workshop overview and objectives, I do want to demo something here that pretty much reflects what I just went over. So just give me 1 second.
Hi, Blake. Blake, we cannot see your screen.
Yes, 1 second. I'm switching the window for the demo.
Yeah, sure. Just making sure everything is good.
Okay, can you see screen?
Yeah, perfectly all right.
Okay. So this is the chat interface here. So this is a standardized interface. And here you can prompt the model. So just bear with me 1 second. I uploaded a PDF file so we can perform RAG and do similarity search here. So the file that I uploaded was Oracle Database New Features Guide. It has some summarizations and information regarding the features of Oracle Database 19c. And essentially, me uploading it was putting it into the agentic system. So if I wanted to use this tool, for example, which is, you can call it the Get PDF tool or Retrieval-Augmented Generation, I can. And what's even more interesting is there's an email tool that's also hooked up to this infrastructure. So if I wanted to do something like this, hey, what are the top 5, or even better, can you list 5 features from the document and create an email template to send to DJ. Okay, so essentially, I was just making sure both steps were concurrently done. So it went into the document, and this can be any document that you want, right? It could be a loan document. It could be any document that you are willing to do any semantic searching on or agentic work. And yeah, so essentially I asked it what were the 5 features from the document after uploading it. It went through, obviously performed some vectorization and some things underneath the hood, but essentially what we talked about here and what the agent is capable of doing is performing multiple tasks that are generally complex at hand and very, 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 very quickly. There's no way I could have done this in a reasonable amount of time. And so, yeah, so here we have the 5 features. And then it sent an email to VJ, and I can confirm that it did as well, but I can't show that information for this call because it'll require me to pull up my email. But essentially that's what it does. So I did want to show you guys that. And that's pretty much what you guys are going to be doing when you guys create this agentic LangChain application. And let me go back to my presentation. So we put together a guide or a workshop to teach you how to build these agents yourself. So you'll learn how to use these agents with tools, prompts, and memory all together. And then you'll also learn how to build these AI agents with Python and LangChain, as well as implementing AI vector search and relational queries, creating custom tools for PDF, email. We just saw 2 of those there, and data tasks. And then obviously you'll have your workshop objectives. So the first one will be your environment setup, which is pretty straightforward. And then your custom tool development, where you can build your agent tools, where you design effective prompting for the third, to make sure your agent is running intendedly. And then agent implementation, where you inference and run the agent. So if you follow all those steps, you'll be able to run these agents in no time. And then, so let's see. So this is just, yeah, so it takes about 45 minutes to complete. It'll also help you understand kind of what's going on behind the hood. And as it's happening, it'll explain it to you, so you know exactly what's going on. I like to do these labs with Oracle when I want to learn something as well. So the first lab will take you through the agentic architecture and code walkthrough. You'll just start to understand the fundamentals, the architecture, the code structure, where the environment's set up, and a little bit about the tools. And then for the second lab, you'll demonstrate AI agent reasoning with examples. You'll see the agent in action with various reasoning tasks. And that's kind of where the theory meets practice. And then for the third lab, you have, which takes about 15 minutes, you pretty much do all the fun stuff. So you run an interactive agentic application, and you can interact with it there. So for the first lab, this is just a screenshot where when you do spin up the environment and you go to the live lab, you will have a Jupyter Lab notebook available to you where you can access it from the activities menu, where you open a terminal window, and everything will be pretty much intuitive there. The lab goes through all of these instructions with visuals as well, so you won't get lost. And if you do have any questions, feel free to reach out to me as well. I'm here. I'll provide my email at the end of this call. So this one's pretty cool. So you can design effective agentic workflows using LangChain's framework. And then by the end of lab 1, you'll have the agentic AI ready. And then this is where you observe the agent's thought process. You could try modifying some of these tools as well here. I know I had a customer doing that last week. He wanted to modify some of the tools, do his own thing. You could do that here. We also provide links to Oracle Database 23 AI docs, LangChain, Python documentation, so you have that as well. Also vector search in the GitHub repository with all the code as well. All right, I think that's it. I'll leave you with key takeaways. And just to summarize, what's important from the workshop, and the core components of the AI agents and how they work together are pretty important. So the LLMs, memories, and the tools. What Oracle is very powerful at with the AI vector search, embedding storage, as well as integration with LLMs. You'll be able to understand why 23AI is pretty unique in terms of the AI data landscape and platform. And then you also get to use LangChain framework to help you structure your code and leverage some of these abstractions. And then you also get to learn about custom tool creation. So you'll gain a lot of practical skills here while using Oracle's converged database. And yeah, so here's the link to the live lab. I think Nikki is going to provide it in the chat. Seeing is believing, so it's really good to get your hands on these labs when you can, so you can see the effectiveness that was just professed today. And if you also want a guided experience or a scheduled workshop with me directly, you can reach out to me. There's my email. You can take a picture of it if you want. Leave it up there for 5 seconds. Okay. And then, so here's some of our resources to make it even easier for you. We provide free tier resources so you can get started without any cost for Oracle Cloud Infrastructure. And for Oracle Database, including 23AI with all the capabilities we've discussed. And I think the free tier is genuinely useful because you get real compute and real database capacity that you can build test actual applications on. So it's pretty good advantage there. And if you're really interested or want to dive deeper into Oracle's AI future and what they have laid out for the rest of the year and years to come, as well as seeing more use cases that some of our customers are using and partners, you can register by taking a picture of this QR code, and you'll see a wide range, at least the full breadth of what Oracle is doing with AI across all of our products and platforms. It's also a great opportunity to network with others and build AI solutions. Finally, your feedback is really important to us. We want to know what resonated with you, what was confusing, and even maybe what you would like to see more of. So your input helps us improve these workshops and create better content for the next group of people and for the rest of the community. So, yep, thank you for all your time today. And are there any questions?
All right, so Blake and meantime, we'll wait for any questions from the attendees and the joiners, and we can answer to that questions. So folks, feel free to drop any questions you got. We still got a time, 10 minutes more. In meantime, we can get connected, and don't worry about the slides and the recording that will be available on Discord channel and the link. So as to what link you are asking for, do you want the Discord link or the survey link? The presentation. Okay, so as to the presentations, slides will be available on Discord channel. Once we are done with the workshop or webinar, I'll be posting everything on our Discord channel. Let me share you the Discord link.
Ashu, are you here?
Yeah, I can see one question from Daniel, and Rajat is asking for the same thing, right? So in order to get a tool list to an agent, right? So agent is given a list of available tools which has the description for what each tool does, right? What are the needs of that particular tool? Then LLM probably read that tool's description and reason about the query, and then probably that select the most appropriate tool on top of it. Right.
Yeah, so
Okay.
the tools will only be used if they're available. If there isn't a tool, it's almost like a kitchen. If you go to a restaurant, this might come off a little funny too, but if you go to a restaurant and you ask for or if you go to well, I guess you can order steak at a seafood restaurant, but let's say you couldn't order steak at a seafood restaurant, you ordered it, it's not available, they won't be able to do it for you. So it's pretty much the same methodology there, if you think about it in theory.
Right. The same the Blake demo, right? It has a send email tool and prepare email tool and get rack tool, right? If you ask the same agent to provide some of the latest web search, it won't able to do because that agent won't have the access to web search tools. So something like that, whatever the tool having those access to the agent, based on those only that can perform the reasoning and selecting tools on top of it. Any specific template? Yeah, there are multiple templates. So basically, as we have shown in the first slide, so we have the MCP server concept. So you can connect multiple MCP server to your agents. What MCP server does is it has a list of tools available. On those MCP server, we have the proper tool description, what are the input required for those tools and what are the output required for those tools. So this is where the current world is moving toward, right? How they're connected different MCP servers. So like you are seeing Oracle having launched their multiple MCP servers, like to connect with the database, to connect with the OCI resources, to connect with other tools also. Similar way, we have the AWS tools to getting all those resources for them. So based on that, your agent will get the tools knowledge. It will perform all those actions based on the tools available to attach those agents.
Yes, and then somebody also asked about frameworks. Like how do you prompt these models? Like, is there a certain way you talk to them? What type of dialect do you use? That's actually a very good question because they all these models they're all natural language. So they don't really understand empathy. So you need to make sure your prompt is very clear. And ironically enough, there's a framework called the Clear framework, which focuses on 5 main components like context, logic, and reflection in action to maximize some of the outputs you probably want for clarity. And these frameworks are publicly available. This isn't something that Oracle gatekeeps. You can find these online by looking up good prompting frameworks. There's also the ACE framework, and they'll give you context on what you need to do based on your use case. And you can also reach out to my email as well, and I can provide maybe some of the prompts that we use for the demo that I just showed you, if that's more of what you were looking for. And then somebody asked a question about the up-to-date with the fast-moving pace of it's. Yeah, so that's a very good question. It's very hard to keep up-to-date with everything. But I found the algorithm helps me out a lot. I use Google and I search AI quite a bit. So I have Google News.